This video is about finding the inverses of one-to-one functions. Okay, first we're going to find the inverses of functions algebraically, and here's your steps. First thing is you're going to replace the f of x with a y. Second, you switch the x and the y variables completely. Then you solve it for y, and your final bow on the package is to replace the y with the f of -1 of x. That is the symbol for inverse. So we're going to follow those steps in those next two examples. All right, f of x equals 5 minus 3x equals 2. All right, so the first thing we said is to replace the f of x with y. Step 2 is to switch where the x and the y are. So it's going to be x equals 5 minus 3y over 2. Now I need to solve this for y, third step. So in order to solve it, I'm going to multiply both sides by 2. That'll cancel, so I have 2x equals 5 minus 3y. Again, I'm solving for y, so I subtract 5. 2x minus 5 equals 3y, dividing by 3. So y is 2x minus 5 divided by 3. I can't reduce any further. The last step says to replace y with the inverse symbol, f of -1 of x equals 2x minus 5 over 3. Okay, there's my inverse of this first equation. Second one, following the same steps, I'm going to replace f of x with y equals the cube root of x plus 1. The next step is to switch x and y. So x now equals the cube root of y plus 1. Now I need to solve it for y. In order to undo the cube root, I have to cube both sides of the equation. So I have x cubed equals, when I cube the cube root, whatever's underneath just comes out. Now I solve for y by subtracting 1. So x cubed minus 1 is now y. Final step is to replace the y with the f of -1 of x symbol. So it's x cubed minus 1. There's my final answer. Algebraically, I have found the inverse. Now we can find the inverses graphically as well. If AB is on the graph of a function, AB is any given point, then BA, notice I switched the x and the y's values from the original, is on the graph of its inverse. So you're just looking to see that the x and the y values are being switched. So you'll have problems that look like this. Are these functions inverses? So the way to do it is to create xy tables for each one and compare the results. So for this, I'm just going to make it easy, 0, 1, 2, 3 for my x's. Plugging these in, put a 0 in for that, I get a 0. 2 times 1 is 2, 2 times 2 is 4. Now, in order for these to be inverses, what my y's were have to become my x's over here, and my x's have to match the y's of the second equation. So I'm going to take my y's and put them in for x and plug it in. 0 times 1/2 is 0, 2 times 1/2 is 1, 4 times 1/2 is 2. So now the question becomes, do the y values match the x values? If they match, if it's a yes, then they're inverses. If they don't match, then they are not inverses. So you take your y values, plug them in for the x's, and then solve and see if they match. Okay, one-to-one functions. A function is considered one-to-one if it has an inverse, if it exists. How do you know? Well, it's a very simple test. It's called the horizontal line test. It says a function has an inverse if and only if, that's what this means, if and only if no horizontal line intersects the graph more than once. Similar to your old vertical line test, horizontal line cuts this way. If it touches the graph more than once, then it does not have an inverse. If it only hits it one time, it does have an inverse. So it is considered one-to-one. All right, so you need to get comfortable with one-to-one means it has an inverse. So here, real quick, do these functions have an inverse? Or it could be asked, are these functions one-to-one? Same question, means the same thing, perform the same test. It's the horizontal line test. So in example 4, if I draw a horizontal line It hits the graph in 2 places. That means there is no inverse. Therefore, not 1 to 1. Okay? Example 5. If I draw a horizontal line, it only hits the graph in 1 place, so it does have an inverse. So it has an inverse, or, depending on how they word the question, it is 1 to 1. Horizontal line test tells you very simply, will it have an inverse or not? So for your whisk, here's what you're going to do. You're going to answer this question for me. Are these two functions inverses of one another? See part B, example 3. This is the one where you do the x, y tables, guys. Pick some values for x, generate your y's, and then substitute them in for the second equation and see if they are reverses of one another. Okay, go back to example 3, and you'll see how I did it on another problem. So on your whisk, you're going to tell me yes or no. These are inverses or not. And be prepared to defend your answer with your work tomorrow in class. Thanks.